Hi, I'm Phil, and today I'm going to play a game on my computer, Pick Up the Plastic. And it's all about improving our awareness of the detrimental effects of plastic in the ocean. So picking up the plastic is about a fishing boat that tries to remove as much plastic as possible. And this game was part of the Microsoft Makecode Arcade game competition last year, where the theme was climate crisis. So the objectives of the game are to score points for picking up plastic in the ocean and to save the fish. And you're going to lose points if you collide with a fish. So on the left, you can see the game console. In the middle, there's a fishing boat, and it's surrounded with plastic bottles. And the idea is to move the fishing boat and pick up those plastic bottles. So the hardware we're going to use is both a Windows PC, where we simulate the game, and we can also use a game console. And this particular one will be the Microbit version 2, together with the new bit for Microbit from KittenBot. And with this configuration, you have to also supply your own batteries and battery box. So besides environmental concepts, the learning concepts of this exercise are to learn how to make games. And these include the concepts of tile maps, being able to use sprites in the game, and head-up displays. And an important aspect is that besides programming, this is also an interesting exercise in art and graphics design. And in the graphics, we can go further than just creating static images. We can create animations, objects or sprites that move, and we can also have visual effects. And within the Microsoft Arcade system, these are simulated using the particle systems, such as things like explosions, fire, smoke, and so on. And we can also add music and sound effects to make our games more interesting and lively. So some of the programming concepts, we can learn more about object-oriented programming, and the objects in the game environment can have properties like velocity. So the sprites can have velocity and acceleration. And we can also use extensions to add additional labels and data to our sprites and objects. And what's interesting, we're using JavaScript and a subset of JavaScript called TypeScript. And that allows us to do both parallel programming and event programming. So when we press a button, it will then take care of that as an interrupt and then proceed to our main loop. So we're learning the traditional programming concepts of variables and constants, but also loops, randomization, and we can learn how to create our own game algorithms. So this game is part of a genre of social games, and it's to engage the user in a important social issue or environmental issue. And one of the aims is to make the gamer or the user aware of what the need is, in this case, to protect the oceans from using too much plastic. And what are the risks in doing that? So one of the game strategies is to reward the gamer with for good behavior by giving them points. And the example that's shown here comes from Microsoft in a separate game competition where they provided additional material. So users had a background about forest fires, and there was additional resources that helped you create your game for that particular theme. So a little bit about the Microsoft Makecode Arcade. So it's part of an old retro gaming system. So these games had their origin in the late 1970s and were even popular right through to 2000. So they're beginning to become popular again, and we're recreating some of these older games. Now the graphics is a little bit limited. There's 160 by 120 points on the screen, and the X and Y direction allow us to fill up the screen with 16 colors. It's only 2D, but sometimes you can go further and with the extensions, animate some of those sprites and create 3D looking objects. The environment has a library of images, both for background and also for the sprites. So the sprites have a lower resolution and the background goes up to the full 100 by 120 resolution. So there are built-in editors into the Makecode Arcade environment, and that allows you to create sprites or edit sprites from the library, and also to create backgrounds for your game. Now, some of the techniques that were learned during the game development of the 1980s and 90s were the platformer style collisions. And these are used quite often in popular games like Mario and so on, where you have to jump from one platform to the other. So besides this, tile maps, animations, particle systems, and being able to simulate using the equations from physics are all included in the game environment. Now for coding, I'm going to use a blocky graphical programming environment, and this has extensions to go a bit further with the programming. The blocky code is translated into a subset of JavaScript called TypeScript. But alternatively, you could use Makecode and do all your game programming in Python. Okay, so it's a good idea to actually have a consistent workflow in creating your game. So we're going to start off by reading what the objectives are, and this might come from your client. And it's also a good idea to use at the right from the start, paper and pencil. Create a storyboard of how the player might use the game, and draw the scenes and the objects, the images in your game. And you do all this before you do the programming. But then you go on to the Arcade Makecode. And the first thing I'm going to do is create the images, both the background and the sprite, and then I'll do the coding. Now, while I do the coding, I need to check for errors, and I get error messages as I'm creating that code. Then I'm also going to watch the simulator to see if it's behaving correctly. If you do that, you'll save a lot of time rather than creating all the code at once, then checking. You might be getting errors right at the end, and it'll take a longer time to trace through and debug your programming. Then when you're happy with all that, test it with the simulator and repeat it if you get bugs. Now you can escape or add to this workflow by downloading your program onto the game console. So if you go across to the Microsoft environment, it'll look like this, and it's got various components. So the part on the right is our work area, and this is where we can construct our code. And in the middle, we have the drawers or the tool box. And the most important one of these appear right on the top. So the sprites, the controller, and the game, they're fundamental. And many of the others are help improve the construction of the game, make it more interesting. And right at the end, there's extensions, so you can add additional drawers to the toolbox and experiment with those. Now, the blocks are two types. There's the container blocks, and I've got one here already called on start. And what we do, we fill up the container blocks with simpler blocks, and these are obtained from the drawers in the toolbox. So on the left, we have the simulator, and the simulator is a full version. So it's in a reduced state at the moment, but you can blow it up to fill up the whole screen, and it allows you to play the game not only on a Windows or a Mac PC, but also on other devices like an iPad, a phone, or a tablet. So the simulator, when you use the normal construction of the game, you can add life and reduce life for bad behavior or for unnecessary collisions. So this is where you would normally get feedback about how many life cycles you've got left in your game. And you can get a score for good behavior and put that on the right. And the integrated development environment of Makecode Arcade takes care of both the life and the score text for you. A good place to start is the drawing editor, and that's what I'm going to do to create. I'm going to create the background and the sprites for my moving objects using that drawing editor. And that's accessible under the assets in the menu bar. So you, if you're going to create another version, you would start here, and this allows you to continue the development. Then when you're happy with everything, you can go to the download area and download it. It will, in this case, I'm going to use the new bit. It's going to create code for the microbit. So it's going to create a .hex file. So the first thing I'm going to do is create my images. And here are my assets. I've already gone in and created these very, very simple assets. The first one was just a background, a blue background for the ocean, and a few waves for the ocean waves. And although the original game had a more elaborate boat, you don't have to, you can make it very simple. So use the sprite editor to create your boat and explore under the sprites drawer what the various blocks are to manipulate your sprite. So I'm going to use a much simpler boat, and I'm going to create simple fish, just reverse those. So I've got two types of fish, and I've got a bottle, a plastic bottle, and I've created all those with the editor. So hop along to the website, go to arcade.makecode.com, and you could start setting up your program. And the program is going to look a bit like this. So we're going to develop the game on the IDE, and we're going to play it on the simulator. And when we're happy, we'll then download it to Microbit with the new bit shield. And this particular game was originally inspired with one of the entrants in the Microsoft competition, and it was called Pick Up the Plastic by the Dutch clearing service. Now, I've made a few modifications to the game to make it more robust. So it's not exactly like the original, but it was inspired by that game. So here's the full code. There's not a lot of it here. And I always start off with on start and put it on the left. In the middle is equivalent to what you might use on other blocky programs, could be the forever container. And on the right, I've got the event containers for the collisions or overlaps between various sprites. So on startup, I'm setting up the background, and I'm also then setting up my sprite. I'm going to call it my sprite for my fishing boat, and it's of a kind player. So here we're seeing a little bit of object-oriented programming where we're adding properties, and in this case, we're adding a label called player. And we're going to do that with the other sprites to distinguish them. I'm going to set up controls using the joystick control. So in this case, my sprite, I'm going to, when I move the joystick, it moves the fishing boat, and it can move it with 100 units velocity. So Vx is 100 horizontally, and Vy is 100 in the vertical direction. Now, I want my fishing boat to stay on the screen, so I use that particular block, and I'm going to set the game life to 3. So the update, or the forever loop, is going to repeat every 1/2 of a second. And the first thing I do is I set randomly and inject the sprites as projectiles from the left or right, and they will be added to the screen of the program. So you can see that I'm setting up the fish as kind fish, and there are 2 of those, and the bottle will be set up as kind plastic. Then I'm looking at the overlap of the sprites. So if the fishing boat overlaps or collides with a plastic bottle, it should increase the score by 1. And I then destroy the plastic and play some music. And the opposite happens with the fish. So if the fishing boat collides with the fish, it will kill the fish and decrease the life by 1. Also gives the gamer a bit of feedback on destroying the sprite and playing some music. So to play the game on the simulator, just press button A and I move the boat with the joystick controls, and I see what happens when it collides with the other sprites. Now, when I've got the game ready, I need to set up the environment for microbit. And I do that by going off to the little wheel there and go to the About area. So in the About area, I want to set up the experiments and turn them on. And that's necessary to go to the next stage. So later on, when you're downloading, you want to make sure that the experimental hardware has been enabled. And that will allow you to download the game in the correct format for the microbit. And when you're ready to download, you need to select N3, and that's the code for the microbit. And after you've downloaded it, you need to test it and reflect on whether the game as you play it meets the original objectives. And can you suggest any improvements? And perhaps you might like to make another revision and version of your game. Okay, so for some of the references, go over to the Microsoft Makecode website, and there are plenty of references there to support you. And an interesting area, particularly if you want to see what others have done, is to go across to the yearly themes that Microsoft have created. So besides climate crisis, and there's plenty of games and code available there, a previous year was the garden theme. And an interesting game there to have a look at is Potato. And it looks at the interaction of bees in the garden. And besides the yearly theme, there's also a day theme that Microsoft set up, the Hour of Code. So they're good resources to have a look at. The other resource to look at is at KittenBot, where you can have a look at setting up the Druitt Arcade Shield, and there's a YouTube video on that. And these are the references for the KittenBot resources. Okay, so stay tuned, and I'll do a physical construction of the game live as a continuation of this video.